Section 7.1 is Introduction to Finite Decimals. And we're going to kind of relate this back on a couple of places to our last chapter, which was about fractions. So we're going to see some interplay between these two ideas. All right, to start with, decimal. The word decimal comes from the Latin word meaning 10. That DEC at the beginning, you see it used in other places as well. Can anyone think of that DEC where you have seen it used and you know it means 10 when it's a prefix? Deca stuff, right? Decagon, decahedron, decade. Yeah, so something with the number 10. In Spanish?
Yeah.
What is it in Spanish? I don't even know.
Yeah.
Diez. It's similar, though. It has a very similar sound to it. Yeah, it's true. So some of the language that you are going to be familiar with, maybe not all of it exactly, but you've seen it all before. We're going to do some placeholders, and there's my decimal point right here. And I want us to do 6 decimal places beyond, so just make 6 more lines. So 2 lines before the decimal point, 6 lines after the decimal point. And what we're going to do is we're going to label the placeholders, and we're going to start on the far left. So what is that placeholder's name on the far left? That's the tens place. There's a couple of names for the next placeholder over. What do you think? Ones is one of them. Anyone else think of something you've heard it called before? Units, that's the other one. Yeah, sometimes it's called the units place. The ones place or the units place. Okay, what comes after the decimal point then? Tenths. And it is hard to hear if you're not listening closely, but that THS on the end matters, right? Yeah, it matters if you have a tenth of something or a 10 of something. I know we don't use the language quite like that, but the language is a little bit different. What's the next place? Hundredths. What comes after hundredths? Thousandths, yes. We've sort of expanded ourselves to being beyond money now, right? We're outside of the decimal points we use in money. What comes after the thousandths place? Good, 10 thousandths. There is a hyphen between the 10 and the thousandths, okay? What are we doing after the 10 thousandths? 100 thousandths. And there's a hyphen there too. I almost forgot mine. I've almost had a space down there. Oh, I have one more listed here. Do you know what comes next? Nope. Try. What do you think? It is millionths. Yeah, so if we were to do the other side, the number that would have one decimal value bigger than the 100,000s, not THS, but would be millions. So this is millionths. And I'm not going to write any more, but let's just suppose, what would you do after millions? Millionths. 10 millionths, and then 100 millionths, and we then need billionths. Yeah, we get to billions. Okay, so we've got some placeholder things. This is plenty enough for most of the things we're going to do. I think there's a 10 millionths one that you run into on your homework, but we'll see that when that happens. What we're going to do is we're going to learn how to say the words properly, like we don't usually do, okay? So I'm going to guess that if you looked at this, and you might do something like I did and say something like this, 32.4236. Is that what you'd say? Probably so. So we're going to say it properly. We start out correct. The first part we say is 32, that part's good, so let's write that down. So we are going to say 32. There is a hyphen between the 30 and the 2, okay? The decimal point is always read in the same way, and we need to read it correctly on that one for sure. Do you know what we read the decimal point as? And, okay? So I have distinct memories from 2nd grade of using the word and in the middle of words that did not have decimal points. Numbers like this. And I would say 327. My teacher would get very unhappy with me because the and shouldn't be used right there because it wasn't a decimal point. Okay, so the word and means that we've got a decimal point in this situation. So we want to say that correctly. All right, what we do next is these 4 numbers here at the end, we write them out as though they were a 4-digit number. Just ignore the decimal point. Just the number that's in there is the number what? 4,000. What's next? 200. Okay, so let's write those down. 4,000. 200. Okay, what's after that? 36. And I'm not trying to be too persnickety about this, but the only hyphens you see are the hyphens that are between 32, 36, and then if you have like 10 millionths, 100 thousandths, things like that, okay? So there's no hyphens anywhere else, and there's no commas anywhere either, actually. So we tend to like to put lots of punctuation in. I don't know, maybe it's an English thing, I'm not sure. So the next thing that we have to do is we've written this number out. We've got to indicate which place value it's in. And we do that based on the last digit, the 6. What place value is the 6 in? It's in the 10,000ths place. So after we write the 36, we're going to write 10 thousandths. So if we had the same thing, like if it started out the same, but it had a 0 here, and then it had the 4236, the only thing that would change is the very end where I wrote 10 thousandths, and it would say 100 thousandths. You guys see that? Yeah. So that's kind of an interesting way in which we use our language there. All right, so the next thing we're going to do is we're going to take this one where it's written out in words. And I want you to take just, 10 seconds to figure out, or 30 seconds, whatever it takes, to figure out what that number should be written as a numeral. Once you think you know you have it, turn to a neighbor and say, hey, is this what you got? Show it to them and confirm. Okay, looks like everybody's sort of calmed down and not talking to anybody anymore, so you must all have an answer written down. So I want somebody to read me your answer just as the numerals that they are, okay? Kind of like I read the first one incorrectly over here, and I said 32, and then I said 0.4236. Just tell me it that way so that we can make sure everybody has it written down the same way. Somebody?
536.076.
Okay, does that match what you guys had? Excellent. All right, we're going to talk about base 10 expanded form. We talk about base 10 form in number theory, for those of you who've had that course as well. But it's a little bit different because we have place values now that are after the decimal point, and we didn't have that when we were doing whole numbers, okay? So a reminder, some of this is a little bit of a reminder, and then an extension. So if you take a look at those place values that we had just a moment ago, we're not going to write them all out, but we'll write down a few of them. So just write the 2 decimals before, or 2 values 3 values before the decimal place. And then we'll write down 3 values after the decimal place. Okay, and we're going to write how much they're worth in numbers now instead of words, like the actual value in numbers. So we'll start on the far left. What is the third value from the decimal point on the left? How much is that worth? 100, right? It's the hundreds place, so anything in that place is a 100. So like if you were dealing with money, anytime you had a number in that place, it would mean a $100 bill, right? Or the equivalent of that, yeah. Okay, what about the next place value? It's 10. How about the next one? That's 1. Okay, now after the decimal point. Yeah, it's 1/10, and I'm going to write it as a fraction because that's where this is actually leading us. This is 1/10 as a fraction. What's after the 1/10? 1/100th. The next one would actually be 1/1000th, and we would keep going, right? We can continue this pattern. When we're working in this section, this is the notation I'd like for you to use. Your book does this. I want you to write it as the 1/10 or 1/100. That's what I want. And the reason I want that is because that gives you the best imagery of what the value actually means. When you write something in this notation as 10 to the -2, all of a sudden things are sort of hidden. The actual image of what that means gets sort of lost in the notation. And my goal is to keep it clear as we're working what value it is we're working in. So I'd like for you to leave it written like this. So even though you look at the back of the book and they put negative exponents, I don't want to see a negative exponents. Okay, it's just not helpful for this content in my opinion. Okay, so check the back of the book, make sure that you got the same answers. That's fine, but it's not going to look the same in your answer form. All right, so let's take a look at writing in expanded form a particular number. So let me show you how that will look. So this is 103 and 3/100ths, right? So how are we going to write that? Well, we're going to write down that we have 1 times 100 plus, and we are going to write the zeros in here. It's 0 times 10 plus 3 times 1, and let me pause for a second. If you think about this one in terms of money, this makes sense. And I know that we have other dollar bills besides hundreds, tens, and ones, but we could just use our hundred, tens, and ones, and this would work too, right? So if you had 103, you have 1 $100 bill, 0 $10 bills, and 3 $1 bills. Everybody good with that? Okay, after the decimal point, we have another 0. What place value is the first one after the decimal point? 1/10, good. And then I have a 3, and it's the 1/100. So this is all it is. So if you're writing it in base 10 expanded form, this is what that looks like. Simple enough? Okay. Next thing we're going to do is we're going to draw a little bit. So there's a really nice imagery, and it's similar to some of the things we did with fractions, but because decimal squares really are grids that have 100 boxes in them, they're common to all decimal values. So if we're dealing with something that's got 1/100th place and no bigger, we can use a decimal square grid to represent it. So this is a grid that's a 10 by 10 grid, and I'm going to draw it with you because I have another option to do this, but I'm going to draw it with you, okay? So we're going to draw a big old square. It is a decimal square, okay? And what our goal is to do is to create 10 rows and 10 columns. So you're going to split this vertically into 10, and you're going to split it horizontally into 10, and a 10 by 10 gives you 100 little boxes. And I'm going to guarantee right now that mine won't be as good as yours probably is. But I'm going to do my best. The goal is for it to look fairly reasonably equal across the image. And all of a sudden I have really fat rows at the end. I just I can't figure out how to do that. I don't have very good spatial visualization when I draw. Yep, I've got fat rows at the bottom too. What can I do? This is where graph paper would be really handy. I can pull up a graph paper, but see, then it wouldn't be like me doing the same thing you are. See, so I'm trying to be modeling for you how not to draw a picture. That's my goal right now. Don't do what I did, okay? Don't make them all look fat and funny at the end. You've got an eraser. Do you? Fantastic. Thank you, Hannah. Excellent. Fantastic. All right, so this is a decimal grid. I mean, roughly speaking anyway, right? It's got 100 little squares. They're supposed to all be the same size. And so we're going to just pretend that they are, okay? So what we're going to do is we're going to draw that decimal square grid now for the number 0.24. So draw it one more time, because if once was good, twice is better, right? Well, you could write yourself a note that says, see the last slide. And I totally cheated, even though I don't like my picture, and I copied and pasted it. So I know you can't copy paste with your paper. I've tried to click on papers when I've been writing things before. It doesn't work. And what you're going to do then is you're going to shade in 24 boxes. Please don't haphazardly and randomly decide what to shade. Do it in a way that easily I can count your 24. So like 2 rows and 4 more. So this would be a decimal square grid representation for the number 2400ths. Another very good imagery for the number 2400ths would go back to looking at things in terms of money. Money is a fantastic visual imagery, especially for kids who already have that established, they're already working with, or they've used money in some sense before. So if you were looking at this, you could talk about having 2 dimes and 4 pennies, right? Don't involve nickels or quarters. That's not going to help your case, all right? You would just be using dimes and pennies to make the argument. All right, we're going to connect some of the things that we did now with fractions before to the decimal stuff we're looking at next. Theorem 7.1, a rational number a over b, those are our fractions, in simplest form, can be written as a terminating decimal. So terminating means it stops, right? It stops. Terminating decimal, if and only if the prime factorization of the denominator contains only 2's and 5's. This theorem tells you have to do 2 things. The first thing it tells you is that you need to reduce a over b, because it says a over b should be in simplest form. So the first thing you better do if you're dealing with a fraction is reduce it, okay? And then the second thing it tells you to do is to factor the denominator. In this case, it's b. Whatever's on bottom, after it's simplified, you factor it. If that number has 2's, 5's, 2's, and 5's, whatever, you're good. It terminates. It will end. Okay, it may be a long decimal expansion, but it will end. If it has anything else, a 3 in it, a 7 in it, a 13 in it, or something like this, it will not terminate. Okay? So that's what we're going to be looking at on the next couple of examples. So I'd like for you to take a look. The first thing you had to do is to do what? Reduce. So 9 and 24, is that able to be reduced? Yes. What would I have to divide both 9 and 24 by to reduce it? 3. All right, so if I divide each of those numbers by 3, what do I get? 3 over 8. Fantastic. Now, I don't care about the 3. The numerator doesn't matter in this discussion. It's only the denominator. So we're going to break down the denominator, which is 8, into factors. So what is 8 if it's broken down? 2 times 4. And what is 4? 2 times 2. So be careful when you're doing this. You want to collect all of the prime factors, and there are 3 of them. And in this case, it's only 2's. Okay, so coming back over here, it says the prime factorization of the denominator contains only 2's and 5's. That doesn't mean it has to have both. It just means it can't have anything else. So does this one terminate? Yes, it does. It will terminate. And it tells us that if it terminates, it wants us to find what number it terminates to. So, like, in reality, could you go back to this number 9 over 24? Yes, but that would be a waste of time. Just telling like it is, okay? Use the terminating one that was reduced because it'll be easier to divide. So we're going to use the 3 over 8. And we're going to divide. We're going to divide the 8 into the number 3. Of course, 8 doesn't go into 3, so we put a decimal point and a 0. And we ignore the decimal point for the moment, okay? So 8 goes into 30 how many times? 3. So I'm going to put a 3 above the whole number 30 where the 0 falls, and I'm going to move the decimal point up. Okay, it's just lined up. 3 times 8 is 24, good. And if I subtract, what do I get? 6. And I will tack on another 0 here because this is unfinished. I'm going to keep going until I get a remainder of 0. Now I'm going to bring my 0 down, so I've got 60. 8 goes into 60 how many times? 7 is correct. What is 7 times 8? 56, very nice. And I'm going to subtract. 60 minus 56 is? 4. Still not a 0, so I'm going to put another 0 up here and bring it down. Oops. 40. 8 goes into 40 how many times? 5. 5 times 8 is? 40. And there's that remainder of 0 that I was looking for, right? So now I am finished. And the answer, if I've written it out as I went, is right here. So, a couple of things about this. You don't even need a back of the book to decide if you did it right, right? You guys have calculators, and that's fine. That's great. But for me to know that you know how to do this all right, I want to see division. Okay, so just grin and bear it. We're not going to do it forever. You're going to do it a few places. Just do the long division, okay? It's not like it's 3-digit division. That's what my daughter's doing in 6th grade right now. I think that's really a little bit over the top myself, but. All right, how about part B? What's our first step? Did you have a question, Hannah?
Yeah, what's
Sorry.
the point of doing the factoring it out if we're going to divide it?
Because if it factors and it has a 3 or a 7 or something like that in the denominator, we won't do that last step at all.
Okay.
That's why. And you won't know that it's going to terminate for sure unless you check it. So you may end up actually doing more work than you have to if you avoid that step. Yeah. 10 and 24, what do I do first? Yeah, I reduce. And so they'll both divide by what? 2. Now what if I did it and they didn't have the ability to reduce? What would I do then? Just go on to step 2, right? Yeah, just go on to the factoring. Okay, so that will happen sometimes too. How does this one factor? And what does it reduce to? 5 over 12. All right, so now we're going to take that 12 and we're going to factor it. So what is 12? 2 and 6, okay. And what is 6? 2 and 3. Some of you might have looked at 12 initially and not done 2 and 6. You might have done 3 and 4. Doesn't make any difference which one you do. Eventually you'll have the same factors because factorization is unique. So this is 2 times 2 times 3. What does that tell you? This is not a terminating decimal. If you actually put this in your calculator, do you know what's going to happen? Any guesses? It is a repeating decimal. And we will get to repeating decimals in 7.3 on how we deal with and what we can do with repeating decimals. So this one does not have a terminating form. All right, next step. Next thing in the list of topics for today, we're going to talk about ordering decimals. How do we order decimals? Well, we line the numbers up by place value. So if they have a decimal point in them, and that's the kind we're going to be working at, we have to make sure they line up with the decimal point. We read them from left to right to find the first difference, the first place where they are not the same, and then we compare the different digits after that. All right, so we're going to do an example. We have a list of numbers, and I know that some of you can look at this list of numbers and not do what I'm about to do. But you're probably also going to make a mistake somewhere along the way, even if you're really pretty good at it, because it's harder to read them, and they're written in a list from left to right. So the first thing we're going to do as we line them up is we're going to line them up one on top of the other. with the decimal point guiding where our lining up happens. We're also going to be very careful that we make the digits the same size. So like when I put in 492, that 2 better be showing up underneath that 1, right? We don't want it to look like it's somewhere else. The next one is 13, and then I've got the 4, 9, 1, 8, and I have a 3, so this one's longer than the first one. And the last one is the 13, and it's 4, 9, 1. Oh, see there I got, my 9 was too big. 9, 1, 2, I'm sorry, 9, 9. There we go. Okay, so as we go through this, I'm going to use a highlighter. The ones all match. That doesn't help me, right? 3's all match, 4's all match, 9's all match. All of that's the same. So the first placeholder where they actually are different, or at least something is different from something else, is in what place value? Thousandths. Yeah, thousandths place first, the thousandths place. And the one that's different is this one right here, yes? Is it bigger or smaller than the other ones? It's bigger. So this is my largest number, right? So let's call this, does it say, it says least to greatest. So if this is the greatest, it would be number 4. Because I'm going to have the smallest one as number 1, biggest one as number 4, least to greatest. For some of you, it might be helpful. Some of you are going to be like, don't need to do this, and that's fine. It might be helpful to put zeros in so that things are the same length. You can do that if that helps you. You don't have to. But now I'm sort of done with this, and I am done with this number. I can avoid looking at it anymore. It doesn't make any difference. So now I have 3 numbers left, and I'm in the 10,000ths place, right? I've got a 9, an 8, and a 9. Well, the 8 is different. What does that tell me about this number? It's the smallest one. So this is number 1 in my list of numbers. So I'm done with this one as well. And now I'm on to the last place. Well, the last place, there's only one number down here. It's a 9. But there's a number here. It's the 0 that I just erased a moment ago, right? So this is where it would be helpful to remember that there is something there. So which of those two is smallest of those two? The top one or the bottom one? The top one's the smallest, so that's what we're going to call number 2. And the bottom one is the largest, so that would, of those two, so it's number 3. Now we're going to write them in order from least to greatest, okay? And you can use less than signs. You can use commas. It doesn't matter to me. I think I'm going to use less than signs this time. So the first one we're supposed to list is the 13. Well, it's this one right here. This is the one I'm trying to list. 49183. This is my smallest. The second one is the one that's on top. It's the 13, and then 4919. The third one, the one that's on the very bottom, is the 13, 49199. And then the largest was the 13 and 492 thousandths. Again, you don't have to have the less than signs. You could put commas in between them. You do need to make sure you're going least to greatest and not greatest to least, so pay attention to the wording of the question. All right. Last question for today. What is the meaning of the word tithe? 1/10. That is the actual meaning. Look it up on like Wikipedia or something like that. Tithe means 1/10. So when people start talking about like I gave a double tithe, it doesn't really even make a lot of sense. Tithe has a meaning. It's kind of weird. Or somebody says I gave a tithe of 5%. No, that's not definition of what tithe means. Tithe means 1/10. It has a meaning. How is that related to decimals? So, okay, it's something out of 100. What did you say, Catherine?
1/10 of something.
Okay, so this is 1/10 of, and when we use it in the evangelical Christian church, we mean 1/10 of our income, right? So in general, it means 1/10 of something. And I'm going to put income here because that's how we use it in our language. 1/10 of something. And 1/10 has other representations. So let's just write them down now so that we're all sort of on the same page. How can I write 1/10 mathematically? 10%, that's one option. That's how we often think about it when we think about tithe. What else could I write? A fraction, so I could write it as 1 over 10. There's one more place I could do, one more thing. A 0.1 or just 0.1. The 0 in front's not important. But there's 3 different decimal or 3 different representations of that phrase, tithe. Okay.